Welcome back, mathematicians. In this video, we are going to learn about symmetry with respect to the x-axis. So we have a graph here that is symmetric with respect to the x-axis. And we can tell that because there exists a line of symmetry, which is the x-axis, and this line of symmetry cuts the graph into two equal halves. So as a result of this, we have a point on the graph that is of the ordered pair x comma y, and a corresponding point on the graph which is of the ordered pair the same x value but an opposite y value. This actually leads us to our algebraic test, where we will replace y with the opposite of y, or negative y, and simplify. So with this test, we are trying to replace y with negative y, simplify, and see if we can go back to the original equation. If we are successful and we are able to go back to the original equation, then that means the equation represents a graph that is symmetric with respect to the x-axis. If we are unable to simplify and go back to the original equation, then that equation represents a graph that is not symmetric with respect to the x-axis. Now let's use that test to determine whether the graph of each equation is symmetric with respect to the x-axis. So what we're going to do here is take this equation and rewrite it, except instead of positive y, we're going to substitute negative y in its place. All other terms will remain the same. Now notice I use parentheses, and it's a good habit to use parentheses anytime you do substitution. So now we have to simplify this equation. Well, negative y quantity squared could be rewritten as negative y times negative y plus 3x squared is equal to 12. So all other terms again remain the same. And negative y times negative y, well, a negative times a negative is a positive, and y times y is y squared. Plus 3x squared is equal to 12. And then we have 4 times y squared, so the product of 4 and y squared is just 4y squared plus 3x squared is equal to 12. And what we notice is that this equation is the same as the original. As a result, this passed the test. This means this equation represents a graph that is symmetric with respect to the x-axis. Let's go to our second equation now, and let's do the same process. So x squared will remain the same, but in place of y, we're going to write negative y minus 4 is equal to 0. We now need to simplify this. There's no exponent to evaluate, but instead we do have a double negative, and the result of that double negative is a positive y minus 4 is equal to 0. Now, there is nothing we can do to either side in order to go back to the original equation. What this means is that the graph of this equation is not symmetric with respect to the x-axis. Now let's look at these equations and their graphs one more time just to see that they are or are not symmetric with respect to the x-axis. So the first equation, 4y squared plus 3x squared equals 12, this graph is actually an ellipse, or what you might have considered an oval back in your elementary school days. And as we can see, the x-axis is a line of symmetry, which means that this graph is symmetric with respect to the x-axis. So it passed the test, and we can see based on the graph that it is symmetric with respect to the x-axis. Now looking at our second equation, x squared minus y minus 4 is equal to 0, the graph is a parabola, and while it does have a line of symmetry, that line of symmetry is not the x-axis, which is why our test failed. So the test failed, and the graph is not symmetric with respect to the x-axis. All right, guys, good luck.